Hello and welcome to Source to Code, your magic decoder ring to demystify the jargon surrounding the technology industry. I'm your host, Ben Coffin, and join me each week as I try to dig into what these buzzwords are all about, how they're being used, and who actually needs them. More big data is on the way as we continue through the back half of our season, looking at the ways different industries approach the idea of data. Last week, we dug into data in the R&D phase in the world of electric vehicle battery testing, where guest Albert Grossmeyer and I talked through how data builds a safer vehicle and creates trust and accountability inside the supply chain. You can find that episode at keysight.com/find/source to code and join our mailing list while you're there to keep up to date on the show as the season progresses. Today, we're digging into the world of manufacturing and looking at the production process through our lens of big data. Now, when I think about the world of manufacturing, I'm taken back to my internship that I had in college where I worked for a major automotive OEM with a team of engineers and operators running a state-of-the-art manufacturing line. Every day, we weary interns would show up for the first shift at like 5:30 and follow around the operators looking for places that we could optimize. We were, as you could probably imagine, a handful of early 20-something interns taking just total shots in the dark to try to figure out what we could improve. We all had projects that lasted the semester or a couple of semesters, improving workflow, and some of us built out physical systems to help the operators. Some of us implemented processes. A rare few got to sit at a computer and sift through data. See, I don't actually know if any of the interns made a big impacts on our line because we didn't know what to look for. See, for the most part, we weren't equipped with data from our lines to see failure rates, success rates, tolerances. We didn't see the measurements that were being taken by each machine, so we could have been hurting just as much as we could have been helping. And that is where we jump into today's conversation. How do we use this data we're collecting to make the right decisions? To figure out exactly how the manufacturing process is changing and how humans are changing along with it, I sat down with Derek Ong, Software Solutions Director for the Electronic Industry Solutions Group here at Keysight. Derek spends his days looking into how the factory is revolutionizing and becoming smart with a capital S, and spearheads how software can innovate in the production facility. So we'll be right back with my conversation with Derek to talk data right after this.
The moment you walk out to the launch pad, it's a unique experience unlike any other one.
It's a game changer for the militaries.
The biggest problem they have is how do I test the application the same way the user is going to do it?
So much more of the capability is embedded in the software and in the touch panels, and that's really where Keysight and the Eggplant capabilities come in.
I'm Allison Friedman, and I'd love for you to join former NASA Chief Astronaut and Navy SEAL Chris Cassidy, Keysight Aero Defense experts, and me as we discuss testing software systems for space and missions at the edge. Join us March 21st at this exciting new webinar. Go to keysight.com/find/space to learn more.
All right, so great. Thank you, Derek, for joining me today. I'm really excited to get kind of a different perspective on the data side of things, because this is maybe further down the line of where I traditionally maybe think, or maybe the listeners think about where data comes in. But it sounds like from what we talked about before, there's a lot of data here. So let's maybe take a step back in history. How in the past was, data captured or used in manufacturing sort of historically?
Well, I think if you look back to the 90s and 80s where the Industrial Revolution happened, factories became more computerized, right? So we had to start at the paradigm, and the objective of that computerization was that data was important to automate and coordinate the manufacturing processes, right? And the whole outcome that they want to get out of this is increased productivity and efficiency, right? So that's the ideal objective that they want to achieve. Now, how they do it is that from the data that they have, they worked on integrated business management systems, things like ERP, SCADA, MES systems. Terms that you may or may not be familiar with, but most people probably are. And these are enterprise level systems that use data throughout different layers of the factory in order to do just that, right? To computerize everything. So every system now and process comes with a computer built in. That was before the Industrial Revolution that didn't happen, right? So the data actually becomes more like a layer cake, right? It's more like, well, it could be more like a pyramid actually. So on the bottom level, you have data that is coming from the system itself or the equipment itself. This is what they call the SCADA, which is supervisory control data acquisition systems. So this just coming from data coming from these systems are just very simple data. Things like what is the temperature in the machine? Is a machine running? What kind of parameters is it running in? Is it operating within the thresholds? And so this kind of data is being output from the system to the SCADA, platform. And factories use this SCADA to monitor and control. If it's getting hot, you shut it down. Things like that. So from the SCADA system, then we move up to the next level up, which is where the SCADA information from SCADA is combined with other information from operators, from manual inputs or humans who take sample data and stuff like that. Essentially, anything else that comes that is available combines it and into a MES system, right, which is a manufacturing execution system, right, or MES in short. Now, this system looks at it from an operational level, right? It asks questions like, what's the yield like? What is the uptime? What is the downtime? So that the factory managers can then make decisions whether to move capacity from this area to the next, to load the orders to this line and that line, to essentially optimize the assets that they have in the factory, right? So the throughput, the capacity. Because that's the role of the factory manager, right? To get the best and the most output out of the factory for what capacity it has. So the MES systems helps them to do that. And then the next level up is more from an enterprise corporate perspective, where you have the ERP system, right? The ERP system is really a business management system, right? Business intelligence systems, and it's really called the enterprise resource planning, right? So the company uses the ERP then to make shipment plans. It combines with customer order data, and really try to track and control from book to order, right? So from book to bill. So these three major layers is what they used to have, and all this is really good back then. But why am I telling you this? Is because by now you could see that the data from the sources, from the systems, aren't very rich, right? So back then, IT systems had very simple data architectures, right? Data warehouse architectures, right? And it was very important that you only take the data that you need, right? The network bandwidth and the server computational power were quite limited, right? It wasn't uncommon for a system to take hours to run a report or query, right? And you could just click a query button on a database, and you could whistle and wait while the icon turns around for an hour before you get a report, right? So and so as you move up the stack, from SCADA all the way to ERP, the data becomes more summarized, it becomes more inferred, right? It's more manipulated, and you only take what you need up to the next level. So you lose a lot of fidelity and granularity of the original source data, right? So basically, in short, data back then was only captured on take only what you need basis, right? The rest of it goes into a bin.
Yeah, it sounds like you may have gotten maybe, let's say, the core idea from enough data, but their context was missing. It was there's not it's an abstraction on an abstraction on an abstraction. And so hopefully, you made the right inference, but you lost a lot along the way. It's funny. I worked in a manufacturing facility for an internship, and this all strikes true with what I remember, a while back. So that we're losing data. We don't have a lot of insight. These systems are generating data, but it's where is it going is sort of a question. So what's the modern approach look like? Post sort of industrial revolution, putting the computer in everything, what's the approach to manufacturing data look like today?
Well, it's been slow, right? Especially for a lot of the electronic manufacturers. It's the adoption of the Industry 4.0 technology. It has been quite slow. Traditionally, it's always been like that. The fintech businesses and for example, the tech industry, they are the ones that are the pioneers, and right? They're leading the way. But
Right.
but yeah, it's gaining ground. So what's happening now is that Industry 4.0 means a lot of things to many people, right? And there's a lot of technology enablers around what we call Industry 4.0. And out of the many, there are three specific enablers that complements each other, right? That really combines into that can drive the digital transformation of the factories, which is what the new modern approach is about. It's not about computerization anymore; it's about digital transformation. So first of all, out of the three, there is the big data technology, right? So if you could handle large sets of data that traditional data processing software and hardware could not, that will enable us to do the next step, which is the next enabler, which is the data mining and advanced analytics, using machine learning and AI and stuff like that, so that we can, start making accurate predictions and correlations. The third one will be the cloud technology, right? So, cloud has high scalability, elasticity, right? So it's able to move as you need. You can handle more compute when you need it. You can scale it down when you don't need it. So the cloud technology also, makes it more cost effective in, when you have multiple factories across the world. So it's a global data service solution, right? And cloud right now can handle big data and the high compute processing required to do advanced analytics, right? So these three technologies, basically enable the modern approach towards data, which is really now is instead of take only what you need, now is go ahead and take all you want.
Right. Yeah. I mean, all three of those things that you hit on are all fundamentally about scalability, right? It's either a totally new scale of data or a totally new scale of sifting through that data or even moving and storing that. So yeah, it now you're at the buffet, right? You've got everything that you can pick from, and it's now you want to get what you want, right? So okay. All right, we've gathered data. We can now we can handle the capacity, the scope of this amount. So when we get it, how do we actually get something out of it? Like what does the data actually tell us?
That's a very good question. There's a lot of opinion on what people want to use the data for. Some are more successful than others, but essentially, the data is more now, right? It's a big data set. It's also much more richer and easily accessible as well. So one of the most powerful thing about this is that you can drill up and drill down the same big set of data, right? So instead of dealing with packaged data that is inferred or stripped off or summarized, now you can pack it and pack the data set at will. So let me give you a visual on this, right? Imagine you have an onion. So onion is like you have the SCADA level, the bottom level of the stack, right? And you start peeling the onion off to get to its core. So as you peel, you move up the ladder, right? You move up the scale, and then once you go down to the middle of the core, you can't put back the layers to make an onion back anymore. It's gone.
Right. Yep.
Right. So with this big data, able to manage big data, right, and keep it and use it and not strip things off, you essentially you're like Doctor Strange in the Marvel universe, right? So you can turn back time. Remember the scene where he, there was an apple, he could move time until it got rotten.
The bite. Yep. Right.
Got caught and then turns back time back to a full apple as it was. That's exactly what big data and all these other technologies in Industry 4.0 can do. Right, that is the power. So if you have a problem at the core, right? Let's say you have a big problem at the core, you can't ship something, right? And now you can actually put the layers back in to investigate what went wrong, all the way down to the source. So you could root cause things easier, for example, right? You could drill up and down as you wish, and nothing gets lost. So that's one of it.
Yeah, you get the connection, and you can, this is something I actually, this is really interesting. It's been fun talking to different experts and seeing parallels. And when I talked to the folks doing digital twin network modeling, it was sort of the same idea that you can see it at sort of whatever abstraction layer you want to, but have the context of the other pieces. And this is really interesting. You get to kind of move through that abstraction with the context brought in from the past. So that's super cool. So let's then say, okay, now we get this data. We can actually figure out maybe root causes, or we can understand
Right.
sort of influential factors, right?
Mhm.
So what changes that? Like, how do we then practically take that data, and what changes on the manufacturing side in order to use that data driven approach?
Well, there's there are a couple of ways you could, well, people are using it right now. One is
Mm-hmm.
that, to do a look back, right? Back to the future, back to the past, look at what happened before, have a serial number and being able to investigate all the layers of the onions, right? The root cause. That's one. Now, the next interesting one is that, for many years, the industry has defined processes to manufacture at the best of its capability, right? So you've got a lot of Six Sigma processes, you've got a lot of best practices, you've got a lot of engineering processes that was designed based around
Mm-hmm.
what was available. Now, what we found out was that nowadays the smarter factories, not all of them, the smarter factories are actually looking at those processes and saying that, what, I'm going to scrap these processes and replace them with processes designed around the big data that's available. So instead of using data to fit into an existing process, I'm going to design new, better processes around the data that's never been available before. So what can I do with the new big data that makes the process even faster, even better, right? Even more accurate, and make life easier, reduce, inefficiencies, maybe even reduce the need for low level headcount, right? More like raise the engineer value to the company, or the operator to the company, by having them do more value added work. So a design, a process that's designed around data will be much better than a process which is using data, whatever data, to fit into it, basically.
Right. I think going back to scale, right? We talked about how really the modern tools, sort of post Industry 4.0, we're looking at, allow us to scale up. One of the things it kind of interestingly does is it also lets us scale down, right? You can focus your expertise in your human headcount, because you've got better and more complete data and data views into the manufacturing assembly.
Right. It's ultimately big data achieves many things, but one of the most important thing is that for any data, right, and because it's bigger, that it's more accurate. So what is that? What does that? What do I mean is that ultimately data needs to help humans make decisions better and faster, right? And big data accelerates that in terms of speed and accuracy, right? So the chances of you making a good decision is higher now, because you got more data, right? You got more regression, right? The more data you have, the more correlation you can find, and more stronger correlations as well, right? So if you make decisions based on one or two samples, that's not the same thing as making the decision based on a million samples. Just like you do any survey, right? So it's that kind of logic,
Yeah, absolutely. You are able to become more accurate over time, right? You
Yes.
by getting those insights, you become more accurate. Well, very cool. Well, maybe one last thing I'll ask, and maybe to just sort of center it around the person who maybe is interested in technology but doesn't know this industry all that well. What's the end sort of advantage to the consumer? Like, they hear about I can get my my car is going to be delivered faster, or my my order off of Amazon's that electronic gets built to meet supply chain. Like, we all, I think, are feeling supply chain pains. But like, like what tangibly do we deliver to the consumer when we implement these big data strategies?
So that's also a very good question. That's also something that's been transforming in the industry, especially in the automotive and some mission critical applications like server clouds and data centers, where the SLA needs to be 99.99. And you can't afford any downtime, right? You can't afford any failure. So
Right.
It used to be that a lot of the data was used to drive factory efficiency and capacity usage, right? Utilization. But what's happening now, especially the material shortages, right? So because of that, people are just throwing money to buy as many equipment they can to secure those systems and hardware to get ready for when the big, to churn out as many products as they can to meet the demand. So you could throw money to solve a capacity issue. You don't need data. Data helps, right? It helps you to maximize what you have. But if you had to, you could just buy more machines. Now, the one thing you couldn't buy, right, is quality. You could throw any amount of money into it, and doesn't mean that the quality is improved, right? Quality comes from many things, and that's where the shift is starting to happen, where the factories are starting to use big data to drive quality improvements and really reduce the cost of poor quality, right? So because at the end of the day, when you ship products out, especially in those markets, they can't fail. If a car, like a branded EV car maker, has a car that gets spoiled or whatever, and then it rears off and hits a rail, it gets on the newspapers, and then you got a big problem. So
Right.
So that's where the big data opportunity is, right? So how the factory can use big data to really drive better quality products, right? And they need, and it's very important for even Google's and Microsoft, where they have cloud services. If you commit a 99.99 SLA, your server boards need to be of really high quality, and you can't afford much failure. Yeah, so that's the paradigm shift we're seeing.
Yeah, absolutely. Well, and that's, the mission critical is a really good way to phrase it. And, that's like, we think about, we're moving to more autonomous systems across, everything from driving to, we're looking at augmented reality becoming something more ubiquitous. And we think about, we want, these overlays, these systems that we're going to, trust. We want to be able to trust them. And so, yeah, quality goes into an entirely new level of scrutiny when we get to that. So, okay, no, I like it. I think that makes a ton of sense. Well, awesome, Derek. Thank you so much for coming on. It's been a pleasure to talk to you. I appreciate the Marvel reference too. Anytime I can relate something through superheroes, I'm here for it. So, yeah, thank you so much.
You're welcome, Ben. Talk to you soon.
So what I'm taking away from that conversation is that data gives us superpowers. I mean, data is like the secret language of the mystic arts. Okay, all right, fine. I'm stretching the Doctor Strange reference here. But it really does give you insight. Insight to be able to sift between processes and operational efficiencies to determine what is working and what isn't. If I had this superpower of data when I was in my internship, maybe I'd be able to spot where the laser welder was going to burn out well before it needed a costly repair. And maybe with that insight, it would trickle up to realize that the metal we were using was causing issues with the welding, which increased the overall rate of failure. See, getting Derek's point of view on how data makes all the difference between informed decision making and following your gut helps contextualize why that data matters way more than just the design and validation phase. And it really ends up being the difference between a good product and a great one. Well, that's all for this week on Source to Code. Join me next week for our penultimate episode of Season 1, where I'm going to talk to software automation expert Toby Marsden about how data gets brought into the IT infrastructure and then how software companies can actually synthesize it once they've built those data lakes. Until then, why don't you tell a friend about the show and let them know that they can find all of our episodes at keysight.com/find/source to code, and they still have a chance to sign up to our mailing list to win a very slick looking Source to Code hoodie that they can wear to rep their new favorite podcast. Plus, this week there is a new piece of companion content along with this episode, studying the correlation between anomalies, which digs into how the manufacturing analytics can actually draw connections between tests and production and identify those anomalies well before your team of interns will. Again, you can find that white paper and all things Source to Code on keysight.com/find/source to code, or you can find us in the link in the show notes. Thanks again to Derek Ong for taking me back down memory lane through the world of manufacturing. Until next time, I'm Ben Coffin, and this has been Source to Code.